Hello students, welcome to ePhysics. Students, in the previous video we have discussed about distance and displacement. We have seen few questions and we have studied about uniform and non-uniform motion. There we have discussed the graphical representation of the object having the uniform motion and non-uniform motion. Here students, we will be discussing two new things, that is velocity and acceleration. So let's start it. The first thing here, students, is velocity. Okay. Now students, what is velocity? Students, we have studied about speed. Okay. Now what is speed? Speed is equals to distance traveled divided by time taken. Okay. Here, when we talk about speed, we only talk about the magnitude. Magnitude means that whether, for example, let us consider it with the example that the speed of the object is 5 meter per second. Okay, here this 5 is the magnitude. If we talk about the speed of the object is 10 meter per second, here 10 is the magnitude, the numerical value along with the unit. Okay, so numerical value along with the unit says as the quantity, and the numerical value of the quantity is known as the magnitude. Students, if we give, and we know that distance have the magnitude only, that is either it is 5 meter, 10 meter, 20 meter, and so on. We have discussed that distance is a scalar quantity and therefore it has magnitude only. Now, what if we give this magnitude a direction? 10 meter per second, 10 meter per second along the direction of north, along north direction. Then here we have the magnitude and along with the direction. When any quantity has magnitude as well as direction, then we say that the quantity is a vector quantity. Clear? And here, when we give direction to speed, okay, direction to speed. When we give direction to speed, this becomes velocity. This becomes velocity. And how will we define velocity? Velocity is change in position with respect to time. Okay, this can be written as change in position with respect to time. When we talk about with respect to time, we are talking about dividing it by time, or the rate of change of position is also known as time. Okay, now change in position we have studied in the first video of this motion chapter, that displacement is defined as the change in position. So change in position means, let us consider the object's final position is x2 and the initial position is x1. So change in position means x2 minus x1. Okay, and if the time taken initially, the time was t1, and finally when the object went to x2, the time taken was t2. So the difference in the time from traveling from x1 to x2, that is changing its position from x1 to x2, is this one, t2 minus t1. So this is known as velocity. We can also write it as change in position, that is x2 minus x1 is equals to delta x divided by t2 minus t1 is delta t. It is velocity. Since velocity is a vector quantity, we denote vector quantity with arrow at the top. Okay, if suppose we are not able to put arrow, we used to write any vector quantity with bold letters. Okay, bold letters, or we can write it as vector v. Clear? This is velocity. Now students, what will be the unit of velocity? The unit of velocity it is again similar to the speed, that is meter per second. Here, the unit of displacement is meter and the unit of time is second, which can be written as meter per second. Clear? So this is how we define velocity and we see it. Now students, when we talk about velocity, there are two types of velocities, as we have discussed about uniform motion and non-uniform motion. Here also velocity is of two types, that is uniform velocity and non-uniform velocity, that we will be discussing now. Let's move to the other part, that is uniform and non-uniform velocity. Okay, now first we will see with non-uniform and uniform velocity. Uniform velocity. Now students, what happens if an object travels in a straight line? If it is traveling in a straight line, it means here the direction is fixed. Direction is fixed and that direction is straight line. Okay, straight line. The object is moving in a straight line here. And if we fix the magnitude as well, magnitude is also fixed. If we fix the magnitude as well, let us consider the object is moving with velocity 5 meter per second along the direction in a straight line. Okay, here the magnitude is always 5 meter per second. After first second it is 5 meter per second, after second, after third second, after any interval of time in this motion, the magnitude of the object is always 5 meters per second. And here students, the direction is a straight line. The object is moving in a straight line. And that is why we say this kind of motion as uniform motion. Okay. Now, how will we define it? If an object travels in a straight line and its magnitude is fixed, then we say that the object is in uniform velocity. Okay, uniform velocity. What happens in uniform velocity? In uniform velocity, the magnitude as well as direction of the object is fixed. Okay, it is fixed. That is, it is always constant. That is, the object is not changing its direction as well as the magnitude also. Okay, students, now when we talk about non-uniform velocity, okay, when we talk about non-uniform velocity, here students, what happens in non-uniform velocity? Non-uniform velocity. Now, when an object travels and its magnitude is fixed. Let us consider the object is traveling and its magnitude is fixed, that is 2 meter per second. And it is continuously changing its direction. First it was traveling in this direction, then it moved to this one, then it moved to this one, then again it moved, and again it moved. And let us see one more example, that the object is traveling in a straight line, but after every interval of time, the magnitude is changing. First it was 2 meter per second, then 5 meter per second, then somewhere 15 meter per second. Okay. Now, in these two examples, we are able to see that here in the first example, the object is changing its direction. Okay. Direction is being changed. And here the direction is fixed, but the magnitude is changing. Okay. Magnitude is changing. And in both these cases, students, we have studied about velocity in the previous slides, that velocity is a vector quantity. That is, it has magnitude as well as direction. So, to change the velocity, we will have to change the magnitude of the object like we are doing here. The magnitude of the object is changing continuously. Therefore, here in this case, the velocity is changing. Velocity is changing. And we can also consider the change in velocity if the magnitude is constant but the direction is changing. As in this example, the direction of the object is changing. Therefore, in this case also the velocity is changing. Or students, we can do one more thing, that we can change both. We can change the magnitude. That is, initially it was 2 meters per second along this direction. Afterwards, it became 3 meter per second in this direction. And afterward, also we can do, students, if we change the magnitude and direction of the object simultaneously. Like, first, let us consider in this direction, the object is moving with magnitude 2 meter per second. Afterwards, it changed its direction in this side and the magnitude also changed. Let us consider it became 3 meter per second, and afterwards it changed again its direction and it becomes 4 meter per second. And here in this case, students, what is happening? The magnitude is changing as well as the direction is changing. Therefore, we can consider that the velocity is changing. Again here, velocity is changing. In the previous two examples, we were changing either of the magnitude and the direction. And here, we are changing both. That is magnitude as well as the direction. Therefore, students, what happens? The velocity is changing. And in these three examples, one thing we have observed, that the velocity is changing and it is not changing with in a uniform rate. That is, the magnitude might change. Like here, like you can see over here, that it might travel in a straight line, but after every interval of time, let us consider after 10 minutes, it became from 0 meter per second to 10 meter per second. And after next 10 minutes, let us consider after next 10 minutes, it became around 29 meter per second. And in here, students, you can see that the change in time is constant. Change in time is always 10 minute over here as well. But the change in magnitude is here. It increased by plus 10, but here it increased by plus 19 meter per second. Therefore, in this case, we can clearly say that the magnitude of the velocity of the object is changing, but not changing with a continuous or uniform rate. Therefore, this kind of motion is known as non-uniform velocity. What is non-uniform velocity? We can define it as if the object is changing its magnitude. Okay? If the object is changing its magnitude with non-uniform rate, that is, it might increase in magnitude or the magnitude of the object may decrease. It may increase, it may decrease, but it is not increasing or not decreasing with the uniform rate. Okay? Then the velocity is said to be non-uniform velocity. Clear, students? So that's it with the velocity part of the video. In the next video, we will be discussing about acceleration, and hope you understood the video very well. Thank you very much for watching.